viewers to Prime Educational Lab. My name is John Okubi and I'll be taking you guys on chemistry. As we all know, every element in life are being bound together by a force of attraction. Now, we are going to be treating balancing of chemical equations. First, to balance a chemical equation, we have rules that governs the processes. One, which is the law of conservation of mass. The law of conservation of mass. The father of atom, which is Dalton, he made it clear that atom can neither be created nor destroyed but transferred from one form to another, which goes for energy also. Now, there is also another rule which states that there's also another which states that product and reactant formula cannot be altered, cannot be changed. What this is trying to talk about is if A plus B gives you C, that's A reacting with B gives you C, it cannot be changed. A can't be changed, B can't be changed, and C. If C is having a subscript, it can't be changed. What can be changed are the numbers in front of each of these elements. So basically, if you're reacting A with B, it can't be changed. This is the reactant and this is the product. They can't be altered. The number 3 rules is carrying out atom count. Carrying out atom count. What this rule is talking about is if the product and the reactant, or if you're being given a chemical reaction, a reactant reacts to give a product, you must carry out the atom count, and that atom count must correspond to the law of conservation of mass. For instance, if 2A plus B reacts to give C plus D, this indicates that 2A plus 1B equals what? 3 atoms here. 3 atoms here. And C plus D gives you 2 atoms. The law of this doesn't correspond to the law of conservation of mass. Therefore, you have to balance the equation by putting either 2 here or 2 here, which makes it 3. Now, this is just alphabetical explanation. Going on to real chemical equations, I'm going to explain further. So basically, these are the 3 major rules in balancing a chemical equation. Now, let's talk about our first example, which is reaction of ammonia plus oxygen. If you react ammonia plus oxygen, it gives you nitrogen oxide plus water. Now, this is an example of a chemical reaction. This can be represented as A, this can be represented as B, this can be represented as C, and this can be represented as D. Mind you, this equation is not balanced. So this is unbalanced. This is unbalanced. Now, for you to balance this equation, first, we draw a table called atom count. We're having how many atoms here? Or how many elements rather? We're having nitrogen, we're having hydrogen, and we're having oxygen. So we'll be balancing each of these elements. So we come here and the number one element, which is what? Hydrogen. Number two, we're having nitrogen. And number three, we're having oxygen. Now, there is something you're also going to put into consideration, which is there's a reaction on the right hand side and there is a reaction on the left hand side. This is the right hand side, this is the left hand side. This is the reactant and this is the product. Now, we put left hand side, we put the left hand side as the reactant and we put the right hand side as what? The product. This atomic count or this atom count signifies that we are going to put the number of atom for the left hand side and the number of atom for the right hand side, and we are going to sum them up to make sure they balance properly. Now, first we are going to consider balancing the hydrogen atom. The hydrogen atom on the left hand side, we're having 3, but on the right hand side we're just having 2, which is not balanced. So for you to balance that, you put a 6 here. You put a 6 here, which means we're having how many hydrogen atoms? We're having 6 times 2, which gives us 12 hydrogen atoms. Now, if we're having 12 hydrogen atoms here, we're also going to have 12 hydrogen atoms here. Now, what are we going to do? To make this 12 hydrogen atom, we put a 4 in front of our ammonia. So 4 times 3 gives us 12, and 6 times 2 gives us 12. Now, we're having how many? We're having 6 hydrogen on the left hand side and 6 hydrogen on the right hand side. Now, going on to balancing nitrogen, we're already having 4 nitrogen on the left hand side, which is the reactant. So for you to balance that on the right hand side, that's the product, you are to add 4, which is what? 4. It gives us how many? 4 nitrogen on the right hand side and 4 hydrogen on the left hand side. So we are now having 4, 4. This is corresponding to the law of conservation of mass. Now we move to the third element, which is oxygen. Oxygen, if you look here, there is an oxygen present in water and there's also an oxygen present in nitrogen oxide. So if you calculate here, we're already having 6 oxygen, and come here, plusing it with this, we're having how many? All in total, 10 oxygen. Now, if you plus them, you understand that we're having 10 oxygen. Coming here, we need to balance it on the reactant side, by putting 5 here, and 5 times 2 gives us 10, which means we're having 5 oxygen on the left hand side and 5 oxygen on the right hand side. If you plus this, you find out that we are having 6 plus 4. 6 plus 4 is 10, right? Then 10 plus 5, which is 15. So we're having 15 on the left hand side and 15 on the right hand side, which means this equation is now balanced. This corresponds to the first law, which is the law of conservation of mass, and the second law, which is we did not alter any of the elements, rather we balanced it. That's the only way of balancing a chemical reaction. You add up numbers to balance it properly. And that, viewers, we've come to the end of balancing a chemical reaction. Thank you for watching.